So, like, if you can invert it, I guess, with it still being a function.
Okay, yeah, so that's essentially what I'm talking about, domain
Okay.
and range.
Uh-huh.
So he has the, standard example of y equals x squared, right? So the whole idea of inverse functions is we want to undo what we've done, right? And so what have we done to -2? We've turned it into 4. And what have we done to +2? We've also turned it into 4, right?
Uh-huh.
So so f of -2 is the same as f of 2, which is 4. How do I undo 4?
You switch it, so it would be f of 4 equals f of -4. You switch the x and y.
Be careful. You're thinking about like the mechanics of it.
Oh.
I'm just talking about like here's a function, right? Not here's a function. Here's a domain. Here's a range, right? And here's the function. Okay. Do you understand what I mean?
Yeah.
When I'm like drawing this
Yeah.
nonsense. Okay. Draw the inverse function. Wait a minute. It's not a function
Right.
because this thing can't go to two things.
Yeah.
So we've got to pick one, right? Which means that we can't have both of these in the domain, right? So we pick this one, I guess. I don't know.
Okay.
Okay. How do you fix it for square root nx squared? Right? Like, if f of x is x squared, right, then the domain is everything. And the range is 0, infinity.
Yeah.
Right? Which means that for the inverse, f inverse will have domain and range switched.
Okay.
Okay? It should have domain 0, infinity, and range equal to r. Right? But it doesn't work.
Right, as a function.
We have to go in and fix it by doing this. So we correct the situation by narrowing the domain.
Right.
Okay?
Yes.
It will serve you well to get your head around this sooner rather than later. Because this is the kind of thing that, like, it's purely abstract. And you can, go in circles in your head trying to think about it. Does that make, like, the fact that you can go in circles in your head and the fact that it's confusing, does that resonate with you? Good. Because, so I'll give you an example of the inverse functions. Have you talked about logs at all?
Not yet.
The definition of log is that it's the inverse function to the exponential. Okay. I mean, we just covered logs. But Do you know when you talk about logs? Is that like the next thing that you talk about?
I don't know.
Okay. Mechanically, solving for inverse functions is you just do it, right? You switch
Yeah.
y and x and just do it. But what about something like y equals x cubed minus x? First of all, do you know how to graph this? X cubed minus x?
Mm-mm.
Where would you start?
I would. You would go down, I guess, however many x's are on the y-axis.
How about plug in 0?
Okay.
Like, so, all right. What's another number to plug in? 1. Okay, it turns out it's 0 at 1. Right? What about negative 1? Oh, it's 0 again. Right? What does that tell you about y equals x cubed minus x? Do you remember?
It's a line.
No. So I have a polynomial. And I know that p of 0 is 0. I know that p of 1 is 0. And I know that p of negative 1 is 0.
So it's reflected.
Remember that the only way for a polynomial to be 0 when you plug in a point is if that number shows up as a factor.
Okay.
Right. Like, as a simple example, like p of x is x squared minus 3x plus 2. If I plug in 2 and if I plug in 1, I get 0.
Yes.
Right? So that tells me that p of x is x minus 2 times x minus 1. Right? That tells me that this thing is x plus 1 times x minus 1.
Okay.
Anyway,
Oh yeah.
the answer to how do you graph this is, or the answer to how you graph anything is you look for the x and y intercepts first. At least that's how I do it.
Yeah.
And you kind of know, like, for huge values of x, it's doing this, and for huge negative values of x, it's doing that. Right?
Yeah.
And does that in between. Okay? The issue, though, is, like, we have this whole region of crappiness where we have a bunch of points that get we have a bunch of y values that have multiple x values as sources.
Okay.
Does that make sense? This is the kind of thing I would have expected of, like, your teacher last year to throw stuff like this at you.
Okay.
Meaning, like,
I mean, he did a little bit, but it wasn't.
when I say stuff like this, I mean random hard problem that doesn't really have a recipe associated with it. Right? So basically, how do you fix this whole problem? One way to do it would be to just cut out this whole region, and now you've got, like, perfectly valid part works just
Yeah.
fine, right? So the inverse, whatever, domain and range, I don't know
Mm-hmm.
how to say what I'm trying to say. But throw out these numbers
Okay.
and you'll be alright. Anyway, still conceptual. And he talked about how to graph the inverse function.
It just reflects over y equals x.
Right. So in this example, how would I graph the inverse function? I would take this point and it would do that thing.
Yeah.
The thing to take away with what I'm doing right now is when I'm reflecting across y equals x, I am not doing artwork. I am saying, okay, this point, when reflected across y equals x, becomes this point. Right?
Yeah.
This point is on y equals x.
Uh-huh.
And then I say, okay, connect the dots.
Yeah.
Right? Otherwise, you'll give yourself a headache trying to. And looks like I gotta eliminate this point right here. Also, because again, let's look at what happens when we try to reflect this across y equals x. This boxed point becomes this boxed point, and I have to pick one. Whoops. I have to pick a favorite between 1 and -1.
Mm-hmm.
And the choice is easy. 1 is the favorite.
Yeah.
Anyway. Okay.
Mm-hmm.
So there's some artwork for you. This all, like, doing examples like this helps you get your head around the important stuff. I say it's important because this understanding is the kind of thing that'll be useful to you. Who knows when. Now let's switch to mechanics.